Today we are going to talk about measuring voltage. Measuring voltage is one of the simplest and most fundamental things we do in electronics. This is done with a voltmeter or an oscilloscope, which is a voltmeter that gives you a reading of voltage as it changes over time, where a regular voltmeter just gives you the instantaneous voltage that you have at the moment. Before we talk about actually measuring voltage, let's remind ourselves about what it is. Voltage is a type of potential energy. To explain what that is, I'll take this pin. I'm holding it about 1.5 meters above the floor. And if I let go of the pin, then it gains kinetic energy, the energy of motion. However, if I just hold it here and don't let go, it has the potential to gain kinetic energy, but won't get that kinetic energy until I actually let go. So voltage is the same kind of thing. Voltage has the potential to make electrons move, but they will not move if there's no path for them to move. Another way to look at potential energy is let's say we have some mountains, and here's the ocean, and we have a stream going down the mountain. And as that goes down, well, as we start up here, we have potential energy. As the stream moves, we have kinetic energy. And as we go down, we use up that kinetic energy, and thus also lose our potential energy. The lower we go, the less potential energy we have. So we start up here with X amount of potential energy. Here we have 1/2 X of potential energy as we've gone halfway down to the ocean. And when we finally get down there, we have 0 potential energy because we no longer have the potential to go anywhere because we're as low as we can go. And we can take a look at maybe this point and say, well, I have a certain amount of potential energy between here and here, and another amount between here and here. And any two places, I can say, well, there's a different amount of potential energy between the two. Here I have so much potential energy. Down here I have so much less potential energy. I'll call that A and B. So we have differences in potential energy as we go down the hill. And voltage is the same thing, because voltage is always a measure of a difference in potential energy. One voltage is meaningless unless we have another voltage to compare it to. In fact, there's never been an absolute 0 voltage defined, so we can't say this is an absolute voltage of 0 and therefore this other voltage is an absolute voltage. It's always a difference. Our meter has a red lead and a black lead, and the meter tells us the difference in voltage between the two. We normally put our red lead at a higher voltage and our black lead at a lower voltage, and then by design the meter gives us a positive reading. But if I swap them and put the black lead at the higher voltage and the red lead at the lower voltage, then the voltmeter gives us a negative reading. So that's basically the idea of how the voltmeter works, or at least how the voltmeter registers voltage. And just as I can measure differences in potential energy between 2 points in that stream, I can measure differences in voltage potential with the voltmeter. Once again, it's always telling me a difference. Just like any other kind of pressure measurement. For example, if I have a tire gauge that measures the pressure inside of a tire, has a little stick that sticks out. Basically, I'm looking at the pressure inside the tire, comparing it to the pressure in the ambient air outside. So inside pressure, outside pressure. And I'll just, outside. So for example, if I have a meter that's telling me I have 30 psi, that's telling me that the difference in pressure between the inside and the outside is 30 pounds. So I don't know, let's say I have 45 pounds inside and 15 psi outside, then that's a difference of 30 psi. So once again, measuring air pressure is a difference in pressure, just like measuring voltage is a difference in voltage. Remember that voltage is electrical pressure. So now that we've reviewed that, I have my red and my black lead for my voltmeter. And how do I measure voltage? It's the simplest measurement we make. All we do is find a point in the circuit and put the red lead at the higher voltage, the black lead at the lower voltage, and it will tell us, the meter will tell us, what the difference is between those two voltages. So let's take a look at some examples here. Let's start out with just a couple of batteries. Using the symbol for a battery here. Let's say these are two 10-volt batteries. And let's see what voltages I'm going to measure as I put the meter in different places. So what this is telling me when I say I have a 10 volt battery, it means that I have a positive lead, or excuse me, a positive terminal and a negative terminal on each battery. And the 10 volts tells me that the difference between those is 10 volts. This is the higher voltage, this is the lower voltage. Remember, in our class we always use conventional current, which means that our higher pressure is the positive side and our lower pressure is the negative side, and our electricity goes from positive to negative, not the electron flow that is very rarely used anymore, where we follow the actual electrons going from negative to positive. That actually gets confusing, and because it just makes more sense that something would go from a higher positive pressure or higher positive voltage to a lower negative voltage. Remember, the positive and negative are not opposites. We're just talking about a higher pressure and a lower pressure. So once again, we have the higher voltage, the lower voltage, a 10 volt difference. Higher voltage, lower voltage, 10 volt difference. So I take my meter and I want to put my black lead at the lower voltage, my red lead at the higher voltage, and what's the meter going to read? Positive 10 volts. So let's draw that there. Now if I take the same meter and put it here, black lead to the lower voltage, red lead to the higher voltage, difference of 10 volts, meter is going to read positive 10 volts. Now what's going to happen if I put my black lead here and my red lead here? Well, maybe you've already figured this out, but just like the potential energy, as I go down I get different segments of potential energy. Remember, I said as we go down the hill, down the stream, I have so much potential energy here, half of that here, and 0 down here, and any two places I can measure some potential energy. Well, 0 plus 1/2 plus 1 whole, it looks like they add together, doesn't it? Well, voltage does exactly the same thing. I have here my lowest voltage. This is 10 volts higher. This is 10 volts higher more. It's also like maybe stacking two 3-foot barrels on top of each other. I have 3 feet. 3 feet more is 6 feet. Or let's say I have a 10-story building and I build 10 more stories on top of it. Now I have a 20-story building. So just like altitude adds up, so does voltage add up. So once again, if I put my meter leads here, 10 volts, 10 volts. What if I put the black one here and the red one here? 10 plus 10 is a total of 20 volts. Now a lot of times you look at circuits and that will give a particular voltage. You might look at a schematic and it says, oh, at this particular point, there's a resistor just out of nowhere, and there's a test point, and it says, at this test point we expect 13.7 volts. Well, I just said that one voltage is meaningless unless you have another voltage to compare it to. So how can I have a voltage at a particular point? Well, that means that we're assuming some place is my 0 volts. So this is 13 volts higher than some other place that I've decided to call 0 volts. And let's see how we determine that. So could it be over here? Yeah, it could be. If I've decided, that looks like a funky 0, if I have decided that that's my 0 volts, then I'm simply saying there's 13 volts across that resistor. But normally that's not the way we do it. What we do is have our black lead anchored somewhere in the circuit. I'm not going to put it over here yet, but somewhere there, and we've decided that is, let's draw it, 0 volts. Somewhere in the circuit. Somewhere, 0 volts. Put the black lead there, put the red lead there, and I see, there's a 13.7 volt difference between here and here. What about here? Well, it depends on which way the current's flowing. With our hill, with the current flowing from the high to the low, as I go lower and lower, I get lower voltage. So in electricity, if we use conventional current, as I go this direction, I expect my voltage to go lower, more positive, less positive. And so if I put my black lead here, my red lead here, and I read positive, let's put a positive here, make sure we make some sense there, positive 13.7 volts. Now I put my black lead here, I'm going to read some lower voltage here. How much? Depends on how much current and how much resistance, simple Ohm's law. But I'm going to measure some lower voltage at this point depending on the resistance and the current. But let's see how we determine where that 0 volts is. And I'll use these two batteries as an example, because in this circuit, it might be any of two places. It depends on the logic of how the circuit works. If this is just a typical radio, for example, and it just needs 20 volts to operate, and I put two 10-volt batteries in there, then the most logical place to call 0 would be my lowest voltage. So there's my lowest possible voltage, and what I will do when I want to make measurements, I'll take my black lead, put it right there, leave it there permanently. And now I just make all my other measurements with my red lead. So what do I expect to read here? Well, it's 10 volts higher, so I expect that to read positive 10 volts. What do I expect here? That's even 10 volts higher, so I expect that to be positive 20 volts. And anywhere else I might have in the circuit. So here's some resistors representing some circuitry. There's my complete circuit. Now I take my red lead, and I expect no voltage difference here because that's a straight wire, even though if we get down to the nitty-gritty, there's a certain amount of resistance and a certain amount of current. We will lose some voltage here, but we always assume that this is a perfect 0 resistance when we draw wires. So we just assume that I have no voltage loss, so here I still have positive 20 volts. Might be 19.999, but whatever. We're never that close in electronics anyway. And then here I have, let's say, 15 volts. Here I have maybe 8 volts. I'm just making these up because I haven't put any numbers on here, but as I go around the circuit, I measure lower and lower voltages until I reach down here, where I read what? Same thing, I expect the same voltage along this whole wire, so that's 0 volts. And why does that read 0? Well, we can look at it two ways. I've used up all of my potential energy. I have 20 volts, 15, 8, and then finally I've used my last 8 volts down to 0. But another practical look at it is, I now have my red lead at the same place as my black lead. What does the meter tell me? It tells me the difference in two voltages. So if I put the black lead here and the red lead same place, what's the difference in the two voltages? They're the same voltage. So what's the meter going to read? It's going to read the difference, which is 0 volts. So by the time I get down here, I simply have the red lead and the black lead at the same place. So there's no voltage difference, so the meter tells me I now have 0 volts. So that's how I read that around that circuit. So that's our typical circuit, maybe like a radio, who knows what. But there are other circuits where just by the way the circuit works, it makes sense not to have our 0 volts at the lowest possible voltage. An example is an operational amplifier. We'll talk about those pretty far in the future, but I'll draw the symbol for one here. It's an integrated circuit with two inputs and one output and a power supply. And what we're going to do is I don't want to get complicated like that yet, so I'll just draw it over here. This one goes over here, so our lowest voltage goes there, our highest voltage goes there. But the way an op-amp works is we want it to have voltages that go positive and negative. So I want voltages on the output that can go either positive or negative compared to some reference. And my reference voltage will be some input from a microphone, who knows what it is. But I'm going to have an input somewhere, and I want that input to be compared to 0 volts. I'll draw a typical circuit here. I'm going to tie that to ground. What is ground? Ground is two things. One, it's a reference point that we call 0 volts. And it also has to be a point that can either take in or deliver whatever current is necessary for the circuit without that voltage changing. So it has to have a very, very low impedance. Basically what I'm going to do is tie that back to my battery. And because I want my output voltages to go both positive, negative, and input voltages too, because I want to work with both positive and negative voltage, because this particular circuit, it makes sense to have both positive and negative voltages. For example, let's say it's an audio amplifier. So I have basically a microphone coming in here. Well, as I speak, how's the microphone work? This is my microphone. There's a diaphragm in there that moves back and forth, and as it moves away from me, it's going to create a voltage that goes one way, going to create current going one way. Let me draw that down here. So as the diaphragm moves away from me, current is going to go one direction, and as that diaphragm moves towards me, the current is going to go the opposite direction, and the result is I'm going to get, when it's moving away from me, I'm going to get a negative voltage. When it's moving towards me, I get a positive voltage. So this voltage is going, I want to be going positive, negative, positive, negative. Now, without getting too complicated about it, I could measure those voltages with this as being 0, and this as being 10 volts, that being 10 volts, and have all positive voltages, but it doesn't make sense with that kind of circuit. It's confusing. So we want to have our median to be 0 volts. So that's why we want this to be able to go both positive and negative. When we get into operational amplifiers and other amplifiers and AC circuits, it'll become more clear why we want to have voltages that go positive and negative. Now once again, before I move on, to make sure we're not confused, the reason I can have both positive and negative voltages is because I have decided to make this my 0 volts. Now, that 0 volts is not my lowest voltage. This is my lowest voltage. This is 10 volts lower than that voltage. So now if I put my black lead here, that becomes my 0. Wherever you put your black lead, that's your 0 volts. I put my black lead here, I put my red lead there, what's it going to read? Now I have my black lead at a higher voltage, my red lead at a lower voltage, and the meter, by design, is going to give me a negative reading. So voltages below 0 are negative. So now this is minus 10 volts. And of course, if I put my red lead up here, now it's at a 10 volts higher. Now that's positive 10 volts. So now I still have the same 20 volts. Minus 10 to 0, 0 to plus 10, that's 20 volts. So my negative voltage is not the opposite of positive voltage. It just means that I have chosen my 0 volts to be higher than my lowest voltage. So 0 volts, lower voltages are now negative, higher voltages are now positive. So you always thought that, oh, positive is the opposite of negative. Nope. Just a lower voltage and a higher voltage. So negative voltage is just some voltage that's lower than some other voltage. So there we have minus 10 and plus 10, my whole 20 volts. So now my voltage here is 0 volts, and my output can go both positive and I'll leave that as black negative. So that makes sense for the op-amp to have both positive and negative voltages. Let's just go back to the batteries and look at how the voltages measure now. And I've pretty much told you all this. Now I've moved my black lead to here, so that's 0 volts. That's 10 volts lower, so it's minus 10. This is 10 volts higher, so it's plus 10. But I still, if I put my black lead here and my red lead there, I still read what? 10 plus 10, 20 volts. Now, could I put my black lead up at the top and measure from there? Yeah, I could. Extremely rarely done. One case I can remember is the old, like it was the 1966 Volkswagen, had the battery reversed. They had what was called a positive ground, where the highest voltage was actually the ground, and it was incompatible with everything. I don't know if that's being done anymore, where anybody uses a philosophy that the most positive voltage is 0. But we could. So if we decide to call that 0 volts, now what do we have? If I put my red lead here, I'm 10 volts lower than 0, so that becomes negative 10 volts. And then if I put my red lead here, that's 10 volts, 10 volts more, that's now minus 20 volts. That's what we would read. Would we ever do that? No, because it gets incredibly confusing. So most circuits, it's probably least confusing to make our ground at our lowest possible voltage, ground being where 0 volts lives, with plus 10 volts, plus 20 volts in this case. In a lot of circuits, it makes sense to have both positive and negative voltages, so we'll simply move our black lead to here. Now, with my red leads, 10 volts higher, positive 10 volts, 10 volts lower, negative 10 volts, still the same 20 volts, but now just because of the way we're measuring it, we get a positive 10 and a negative 10. So that's the way we measure voltages in circuits. And pretty much once again, all you do is take your voltmeter and touch it wherever you want to, and nothing special, don't have to do anything to the circuit. One lead here, one lead there. In analog meters, you want to make sure that your red lead is always at the more positive voltage or the higher voltage, because that will make the needle move the right direction. If you get them backwards, then the needle goes the wrong way and does not give you a meaningful reading. But with digital meters, if you get the leads backwards, you just get a negative reading, because by design, if the red lead is at the higher voltage and the black lead is at the lower voltage, a digital meter will give you a positive reading. But if you reverse them and put the black lead at the higher voltage and the red lead at the lower voltage, then you get a negative reading. So it's not so critical there, but if you're measuring, you get, oh, negative, swap the leads. Oh, there it's positive. But when you do want a negative reading, that's when we're going to leave the black lead at one point and then read voltages with the red lead. If you found this video useful and informative, please give me a thumbs up down below. It really helps the channel. And subscribe, because that not only informs you when I put new videos up, but it really helps the channel also. And a big thank you to my patrons at Patreon. I could not make these videos without your support. If you want to help me put these videos online and keep real vocational education free at vocademy.net, you can go to patreon.com/join/vocademy and pledge your support. And again, a big thank you to my patrons who make this possible, and a big thank you to everyone for watching.